All right, so in this example, we're going to take a look at the difference between a population and sample, and between descriptive and inferential statistics, and also an example where we use the margin of error. So the example is printed here. We are interested in knowing what all U.S. citizens think about the job that President Biden is doing so far. So according to the website 538.com, which is a website that does a lot of data analysis both for politics, polling, and they do a lot of interesting sports things too, lots of sports analytics. But they keep a running total of the president's job approval. And so I went and got one of the polls they use, which is a recent IBD TIPP poll. It's the most recent poll they have that they give an A rating to. It's actually an A/B, but it's the best quality poll they've had, the most recent best quality poll. So that poll took a random sample of 1,261 folks, and they found that 668 of them approved of the job that Biden is doing so far. So let's apply our sort of initial terminology to this situation. So first off, what's the population here? Well, in general, the population, remember, is the entire collection of things or people that we are interested in knowing about. So the population here is the entire U.S. I guess more specifically, we're talking about citizens. But this one is for all of the U.S., not necessarily likely voters. So some polls will narrow it down a little bit to just those that are likely to vote. This one does not. Now, one of the things that the text makes a point of, which is something to keep in mind all term, because this is kind of one of the reasons for having statistics in the first place. Right, we might be interested in knowing what the entire U.S. population thinks about the job Biden is doing, but it's too big of a population to actually ask everyone, right? So it would be way too expensive and too time-consuming to try to track down every last U.S. citizen to ask them what they think of the job Biden is doing. And when that happens, when the population is too big to ask because it's too expensive or just too infeasible, what we have to do is be content with taking a representative subset of that population, which is called the sample. Right? So we want to know about the whole population. We don't have the money or time to ask everyone. And so instead, we just take some representative sample of the population. And that's the folks that we actually collect data from. So our sample will be, stick with the red font, a subset of the population from which we obtain data. Right, we can't ask the whole population of the U.S., so we have to be content with just some subset of them. In this particular case, the sample then will be, it is, the 1,261 respondents. So those are the folks that are actually in the poll. Now, what about the sample proportion? Well, it's a quick calculation, but we're trying to get a sense for how many people or what people think of the job that Biden is doing. And so one way to get at that is to look at the proportion that think he's doing a good job. So we're going to take 668 and divide that by 1,261. I'm doing that with my calculator real quick. And And so I get 52.97%, so 0.5297, and we're just going to call that 53%. So 53% of respondents approve of the job that Biden is doing so far, of those asked between January 27th and 29th. Now, because we only took a subset of the population, right, we shouldn't expect that 53% to be exactly accurate, right? The sample represents the population, but if we chose a different sample of 1,261 people, we would get different answers and possibly a different, or likely a different sample proportion. So it's always important to, along with a result like 53% approve of the job Biden is doing, to give some indication of how much we would expect that to vary from the actual proportion in the whole population. So that percentage is called the margin of error, and the formula we have here is for proportions, and it's a rough approximation. We'll actually do better later in the term. But let's do that calculation now. So I'm just going to use the equation editor, which is sometimes a little slow. Let's see if it'll cooperate. Wow, that's really slow. All right, well, I guess that's because I'm recording. So I need 1 divided by the square root of the sample size. Right, that's what the little n represents. So I'm taking the square root of 1261, and then I'm going to multiply that by 100%. And now let me do that calculation. So if I take 1261 and take the square root, that's about 35.51. Divided by 35.51 times 100%. So what's my final verdict here? So I get about 2.81. So 1261 square root. So 2.81%. Let me just say 2.8%. Get that one in red. Okay, so in our poll of 1,261 respondents, the margin of error is about 2.8%. So that says we're pretty sure our result is within 2.8% of the actual value. Right? So we have to make precise what we mean by pretty sure. We'll do that later in the term. But for now, we sort of estimate that we're about actually 95% sure that the true proportion of folks that approve of Biden's job so far is between about 50.2% and 55.8%. So that's our inference. So the true proportion for Biden's job approval is, let's say, likely between 50.8% and 55.8%. So the 53 plus or minus the margin of error. And in a way that we'll have to make precise later in the term, that is a result we're 95% sure of. That's what the likely part means. All right, so as far as descriptive versus inferential, the 53%, the sample proportion, that's a description of what happened in the sample, so it would be descriptive of the sample. But when we use that result to make some prediction or claim about the larger population, then we're using inferential statistics, right? So we're not just saying what happened in the sample or some particular data set. We're saying what we think we can conclude based on that data set. So here we have an inference about the true job approval, and we think it's probably above 50%, but no higher than about 56%. And that will conclude this example.